Hi guys, welcome back to my YouTube channel, and today we'll be looking at some of my favorite Kotlin grouping functions. This is not the official title, but it's their general use. We'll be looking at the groupBy, chunked, and windowed functions. The last two are not very common, but they come in handy in different scenarios, as we shall see. So let's get started. The first function is the groupBy function. It's pretty common and is used to group items based on the relationship they have. It makes use of a key selector to group the items. This key selector is a function that defines the relationship. Let's say we have a list of vehicles like this one. We may want to group them according to the length of the strings. We can make use of the groupBy function and define the key selector as the length of the string. This will give us a map where the key is the length of the string and the value is a list of the strings that match the specified length. Another example is where we have a list of numbers from 1 to 9. We may want to group them in terms of even and odd numbers. This means our key selector will be the modulus of the number by 2. The key in our resulting map will be either 0 for even numbers or 1 for odd numbers. A good example of the usage of the groupBy function is in this HackerRank problem, where we have a large pile of socks that must be paired by color, and so we are supposed to return the number of pairs that can be formed from that sock pile. So it's basically an array of numbers, and we are supposed to return the number of matching pairs. Given such an array, we are supposed to return the number of pairs that can be formed from this array. So let's do it manually so we can see how many pairs we can get from this array. We look for the duplicates inside the array that can form a pair. The first number is 1. It also has a duplicate in the array, so we pick those two to form a pair. We look for another number that has duplicates and can form a pair inside our array, and 2 is the number, so it can form another pair. Since there is no other duplicating item in the array, our function should return 2 because we can only form 2 pairs from our array. In our function, the first thing to do is to group the items based on the color, i.e. the value of the numbers. So we use the groupBy function and specify the value itself as the key selector. This will result in a map of the key being an integer and the value being a list of integers. So this will represent the color, and the lists of integers will represent all occurrences of that color inside our array. The next thing to do is to find the number of pairs that can be formed from each of the grouped values. We will make use of the sum of function, which is like a cross between the map transformation function and the sum collections function. It will go through each item, getting the number of pairs and then summing them all up to give us the total number of pairs that can be formed from our array. Our selector will be the size of our groups divided by 2. Let's first remove the type. For example, in our array, the color 1 will result in an array of 3 colors because we have 3 occurrences of 1 in our array. So with this selector, we'll get the size, which is 3, divide by 2, which will give us 1, which is the only pair that can be formed from 3 socks. If we had like 4, then this would be 4 divided by 2, which will give us 2 pairs that can be formed from this array. So this takes care of the floating socks that cannot form a pair. We don't need to worry about that. And with this, we actually have our return value of our function. If we run this, we actually get 2 as we had seen before. So the groupBy function can help us group these items based on the relationships that they have. The other function we'll look at is the chunked function. It's an interesting and powerful function in some cases. Unlike the groupBy function, this one results in a 2D array. The internal arrays are the groups that we have formed. We don't specify a key selector or a relationship in this one. Instead, we specify the size of the chunk. Suppose we have a list of fruits. We may want to group them in twos. This function will give us chunks of two subsequent items, i.e. apples and bananas, pineapples and grapes, and mangoes will be alone in the last array. It doesn't leave out the chunks that don't match the specified size. A practical use of this will be a paging library where you can chunk an entire list of items based on a page size. The last items will still be available even if they are less than the specified page size. A problem that can be solved using the chunked function is the drawing book problem on HackerRank. So basically, we are supposed to find the minimum number of turns that someone has to make on a book to reach to a certain page. So just like a normal book, we have two sides of each book, the left and the right. And so we're given the number of pages in the book and which page we are going to. So you can either start flipping from the front, which starts from 0, or flipping from the back, which starts from the end. So we are supposed to find the minimum number of flips that someone is supposed to make to reach the specified page. Given a book with 9 pages and we need to go to page 2, we need to determine the least number of flips that can be made in order for us to get to the specified page. The first thing to do is to create a representation of that book so that we can determine the least number of flips that can be made either from the left or from the right of the book. In our function, the first thing to do is to create a representation of our book. We can make use of the chunked function to group the items according to pages and specify the number of pages as 2, i.e. the size of the chunk to be 2. So first create a range from 0 to the number of pages, then chunk them into 2. The next thing to do is to get the index of the chunk that contains our page. We can make use of the index of first function to check the chunk that contains our page. It contains our page. So with this, we have the index of the chunk, and this also represents the number of left flips, i.e. that is the number of flips from the start. So let's say we are going to page 2, the index of the chunk that contains our page will be 1, which is also the number of flips we need to make in order to get to that page. If it was 7, then the index would be 3, so the number of flips will be 1, 2, and 3. The next thing to do is to find the number of flips we would make if we were starting from the right side of the book. So we first get the last index, and then we subtract our page index. So this represents the number of right flips. We now have to return the less of these two values. If page index is less than right flips, then page index should be the one that is returned. If right flips is less than the page index, then that is what should be returned. We can make use of a normal if statement, but Kotlin has a function called coarse@most that ensures that the value is not more than the specified maximum value. So page index coarse@most right flips. So if right flips is less than page index, then it's what will be returned. If page index is the one that is less, then it will be returned. If we run our solution, we'll see that the minimum number of flips that are required would be 1. If we were to change this to, let's say, 5, then we'd get 2 flips. So from the end, first flip and the second flip, which also works from the start, the first flip and the second flip too. If we have something like 7, same thing, 1 flip. So our solution works. The last function we look at today is the windowed function. It works similar to the chunked function, but it can have duplicates in different windows. By default, it does not allow windows that are less than the given size, but you can override this behavior by specifying the partial windows parameter. Let's say we have the same fruits list. When we use this function with a size of 2, we get windows with 2 items in each. Notice how the last item in the previous window is the same as the first item in the following window. You can also override this behavior by defining a step parameter. By default, the step parameter value is set to 1. Also, if the step and the size are the same, you are basically chunking the list. It will have the same behavior as having used the chunked function. A good example of the use of the windowed function is in this HackerRank problem, where we have a chocolate bar and each square of that chocolate has a number on it. So we are supposed to return the number of segments that conform to a specified number of instructions or specifications. So one of them is that the length of the segments, or rather the number of the segments, must add up to a specified number, and the sum of the integers on top of each chocolate bar must also match up or should add up to a specified number. And these segments must be contiguous, which means they must follow each other, one after the other. So a good example is given 3 and 2, the two numbers should add up to 3 and they should be 2 segments in each. So in this chocolate bar, we have the first segment where the sum of the numbers is 3 and the number of chocolate bars are actually 2. The number of the squares are 2. Same thing happens to the next one. As you can see, it's still contiguous, but we're still using the second segment inside that chocolate. So it means with this one, we are supposed to return 2, since 2 of those segments conform to the specified details. Given our chocolate bar is this array, and the sum to be 4 and the number of segments to be 2, then we need to determine the number of contiguous segments whose values add up to 4, and these segments should be 2. We can do this manually first by passing our array down here. Then we check the segments whose values add up to 2, and they should follow each other. So the first number is 2, so the following segment also contains a value of 2, which means this segment is actually correct. So we have our first segment. Then we go to the next one, which is 2, 1. The sum is 3, so that doesn't add up to 4. Then the next one is 1. The following segment is 3. The sum is actually 4, so we get that segment 2. And so the last item is 3 and 2. These add up to 5, so that segment doesn't work. So our function should return 2, since we can only have 2 segments that actually meet our criteria. In our function, the first thing to do is to create all possible windows that can be formed from our chocolate bar. So we convert our array to a sequence, since windowed only works with sequences. Then we specify the size as the segments that are provided. Then the next thing to do is to sum up the values of each chocolate bar inside our segment. With that, we are now able to get all the segments that actually match our given value. So count the ones that are equal to the birth date. And with that, we actually have our return value. So with the windowed function, you can easily group them while still maintaining duplicates across each window. If we run this, we actually get 2, as we saw when we did it manually. You can specify 5. None of them match 5. Something is wrong. 3, 2. Oh, You can also change the value here to be 5, where we'll get only one combination, the last two, 3 plus 2. If we change this to 3, we get 1 because 2 and 1 are the ones that can only form 3. So there you have it. And with those methods, you can easily group your items to fit your algorithms or your intended purpose. If you liked this video or found it helpful, leave a like or comment and subscribe, and I'll see you in the next video.